How are you, viewers? Today we're going to look at arithmetic sequences. These are sequences which are obtained by adding a constant value to consecutive terms in order to get the next term. For example, if our first term is 5, this time we want to add 3 in order to get the next term. If we say 5 plus 3, we are going to get 8. That's our term number 2. And then term number 3 will also add another 3, which will give us 11. To get the next term, we are going to add 3 again. It will give us what? 14. So for it to be called an arithmetic sequence, the differences of the consecutive terms must be constant. Like 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is also 3. For us to generalize this sequence, I am going to rewrite these 3 terms here in terms of 5 and 3. Now our first term is still 5, but this 8 here, I'm going to write it as a sum of 2 numbers. It is now 5 plus 3. Remember, we got this 8 by adding a 3 there. And the next term is 11. We added a 3 to 8 in order to get 11. So this is the current 8. Now to get 11, it will be 5 plus 3. This is our 8. We add 3 again. And then for 14, we are going to add 3 to this expression. So it will be 5 plus 3 plus 3 plus 3. This is now 14. Let me just put brackets so that you'll be able to differentiate between the terms. So this is our first term, second, third, and fourth. Now, if we were to continue this way, we're going to have too many 3s. I'm now going to write it in a shorter way. I will express this part here as a product. So the first one here is going to be a 5. The next one is 5 plus, how many 3s are here? There's only 1 3. So we can write it as 1 multiplied by 3. And then at this position, this one here, how many 3s? There are 1, 2. So I'm going to write this as 5 plus 2 times 3. This is our third term. And then the fourth term, we've got 3 3s. So it's going to be 5 plus 3 times 3. So this will go on and on, okay, up to the nth term. Now I want us to analyze these first 4 terms here. But before we do that, I just want to add a product of 0 and 3 here because we don't see any 3, but I can safely introduce it to our first term. There is no 3, so I'll just say 0 times 3. So this will be our first term. Now above this sequence here, I'm now going to introduce the positions. Our positions are going to be represented by letter N, right? Now, this is our first term. It means N is equal to 1 at this position. This is position number 1. And this one here is position number 2. This is position number 3. And this is position number 4. These positions, again, I will emphasize they are represented by the letter N. Now, if we closely check the relationship now between these numbers here, the coefficients which I introduced, this 0, the 1, 2, and 3. What is the relationship between the position and the coefficient of the common difference? This one here is 1 more than that position. So if I say 1 minus 1, I will get the coefficient of 3. This is position number 2, but we've got a 1 here. So if I say 2 minus 1, I'll get that coefficient. The same will apply to these two. 3 minus 1, I'll get 2. 4 minus 1, I'll get what? 3. Now, if I go on and on up to the nth term, position number n, let me use black because screen is not all that clear. Position n, I can still write these expressions here. It will be 5 plus. I need to emphasize that position. It is the position minus 1. We'll get the coefficient of 3. But now our position is n. So we can put it in brackets and say position minus 1 multiplied by 3. So this is the nth term. In other words, any term of this sequence can be represented by 5 plus n minus 1 multiplied by 3. Let's check if this expression is correct by substituting the position of n. Now, if we look at this sequence here, what is the position for 14? It is 1, 2, 3, 4. So 14 is occupying the 4th place, which means that our n is equal to 4. Now, according to this formula, we can simply substitute here a 4. If we substitute 4 here, it will be 4 minus 1, which will give us what? 3. Then 3 times 3 will give us 9. And then 9 plus 5 is going to give us what? 14, which is correct. So this expression is true for this particular sequence. Now, I want to introduce letters which will assist us in terms of generalizing. But I will go back to this line here and make some substitutions. We're going to use the letter A to represent our first term, right? So A is going to be our first term, right? This is 0. You can leave it as it is. And then the second term here, we're going to replace this one. Remember, this is 5, this is 5. So it is still equal to the letter A. Plus, right, instead of 3, we are going to use the letter D to represent the common difference. This difference can be positive or negative. But for generalizing purposes, let us use the letter D here. 1 times D, it will simply give us D. And then the third term, it will be A plus 2 multiplied by D. Term number 4, it will be A plus 3D. If you can check now, these coefficients 1, 2, and 3, they are always 1 less than their position. Now let us move on to the nth term. There is a term somewhere on the sequence, we don't know its position, we will just call it position n. Now, from this general expression here, there are two numbers which are still appearing, which we saw from the side. There is 5 and 3. And we are saying this 5 here is our first term. So we're going to replace that one by A. So this one is equal to A plus n minus 1 multiplied by 3. This 3 is the common difference. I said we're going to use the letter D. Now, the nth term of this sequence is now represented by this one here, because we've got letter A, letter D, and position N. All these ones are the unknowns. So in general, for any arithmetic sequence, the nth term Tn is equal to A plus n minus 1 multiplied by D. This is our formula at this stage, guys. It applies to every arithmetic sequence. Now, let me just try to remind you about the terms. This is the general notation. It represents the nth what term. Tn is representing the nth term. And then this one here is the actual expression which is representing these numbers based on their positions. So this A here is what we call our first term. I think it's important that we master these definitions. A is our first term. N, as you can see, it is the position of the term in the sequence. Position. Right? And then D, this is what we call the common difference. Remember, I said this common difference can be positive, it can be negative, it can also be a fraction, as long as you are adding the same number every time or separating the same number. That's your common difference. So this is a very important formula because it is applicable to all linear number patterns. I'm now going to give you a simple example where you can actually apply this formula here. Let me just clean the board. Right. I think this is okay now. Let us look at this example here. Minus 1, 3, and 7. What are we supposed to do there? We are supposed to find the general term Tn. We are supposed to find the general term Tn. In this case, we are going to apply the same formula that we deduced. Now, the first thing when you want to find a general term of a sequence, you must find the consecutive differences. And it is actually a way of confirming that for real it is what? Arithmetic. Now, what is 3 minus 1? Just be careful because there's a negative sign there. So it's 3 minus 1. The difference between these two. What is our answer here? Is going to be negative and negative, positive. 3 plus 1, it will give us 4. Let's check the next one. Here is going to be 7 minus 3. 7 minus 3 again is giving us what? 4. So this 4 here is our D, the common difference. And then from these numbers here, what is the first one? The first one is negative 1. So this one is our A. A is equal to negative 1. We've identified A. We've calculated D, which is equal to 4. Now, the general term which we derived is Tn is equal to A plus n minus 1 multiplied by D. Now, to find a general formula for this sequence here, we simply substitute your D is equal to 4 and A is equal to negative 1, and then simplify the expression. What is A? A is negative 1 plus, open bracket, n minus 1 multiplied by common difference, which is 4. Here we are not substituting n because for us to be able to calculate the different terms, we will simply substitute the position of the term that we want. When we are removing these brackets, please don't forget you are supposed to multiply 4 by that number there, and then 4 by -1. So it will be -1 plus 4n minus 4, right? This is our Tn, but let us simplify it because these ones can be simplified, -4 and -1 there. What will that give us? It will give us 4n minus 5. So this is what? Tn. So this is our formula representing that sequence. Please, after getting this answer, always check, because you might make a slight mistake. So for you to confirm this, you can do it this way. You can use this term here, or you can use the next one. You know you are supposed to add 4 to get the next term, which is equal to 11. 7 plus 4, you will get 11 there. Let us check here now. 11 is position number 1. 1, 2, 3, 4. So term number 4, according to this formula, is going to be 4 multiplied by 4 minus 5. 4 times 4 is what? 16 minus 5. This will give us what? 11. And it agrees with what we have there. Our term number 4, according to that sequence, is also 11. Right, let us try another example. I'll do it on the side here. In this case, remember, we're just trying to find the formula, which we got as 4n minus 5. Let us look at this sequence: -5, -2, 1, -5, -2, 1. This one will go on and on up to 94. Now, the question is, what is the position of 94 in this sequence? Because if it goes on and on, one of the terms in this sequence is 94, but we don't know the position of what? 94. How do we do it? The first step, you find the common difference of the first 3 terms here. We must be careful. There's a negative and a negative there. So it's going to be -5 minus 2. What is this equal to? Negative and negative, it will give us a positive. Therefore, -5 plus 2, this will be -3. Right? And then the next one, what is it going to be? Sorry, I made a mistake there. It's supposed to be -2 minus 5. Please don't make this mistake. It is always that term minus the previous one. I done it the other way around. So it's negative, which is positive, 5 minus 2. So our common difference is 3. The next one, it is 1 minus 2. Again, negative and negative is what? Positive. So 2 plus 1, it will give you 3. Right, I had made a mistake here. In case you make a mistake, it will give you an answer which is different from that one. Then it must include, oh, probably there is a mistake somewhere, because for a linear sequence, these numbers are always the same. So if you realize that they are different, it means there is a mistake in terms of your calculations. Right, from these 2 lines, this one here, we can conclude that our t is equal to 3. Okay, and then this is our first term. Therefore, a is equal to -5. Tn, we want the position of 94. We know 94 is a member of that sequence. So Tn is equal to 94, but we don't know what n is. This is what we are looking for. What is the position of 94 in that sequence? This is where you bring in the formula now. Where is the formula? It's this one. Tn is equal to a plus n minus 1 multiplied by d. Okay, now from this information here, we can safely substitute now. Our Tn is 94. We put 94 here is equal to, what is the first term? A, negative 5. So this is going to be negative 5 plus, we don't know n, so we simply write it as n minus 1. The common difference d is equal to 3. Is equal to 3. When our common difference is negative, always remember to use brackets, because if you say minus 3, it will be as if you are subtracting 3 from this. So you must always put brackets there, especially when it is negative, to show that those two parts are multiplying each other. Right, let us simplify and solve for n. We are going to remove those brackets on the right hand side. So this will be 94 is equal to minus 5. 3 times n, it will give us 3n. 3 by negative 1, it will give us negative 3. If you check on the right hand side, we have got negative 5 and negative 3. This will give us minus 8, and then there is our 3n there, which is equal to 94. On the right hand side, we've got negative 8. Let us bring it over. It will be 94 plus 8 is equal to 3n. You can use your calculators there. It's 8, 9, 10, 11, 12, 2, carry 1, 10. So it will give us 1, or 2 is equal to 3n. To find n, divide both sides by 3, right? Over 3 here, over 3 there. Please don't stress yourself. If you have a calculator, just punch 103 divided by 3. So 3 into 10 there, it will go there 3 times. Remainder 1. 3 into 12 is 4. So our value of n is 34. I always prefer to write n first and then the value that side. So for this particular sequence, the position of 94 is 34. N is equal to 34. If you keep on adding 3, and our term number 34 is going to be 94. Now to check your answer, just to check here, you can use Tn is equal to a plus n minus 1 multiplied by 3. You substitute this information, and then this is now your 34. It will be negative 5 plus 34 minus 1 multiplied by 3. This will be negative 5 plus 33 by 3, which is equal to negative 5 plus 33 by 3 is 99. 99 minus 5, it will give you 94. There are more examples that we can actually solve using this relationship. But for today, let us end here. I hope you enjoyed going through the process as well as the application based on these two examples which I gave you. We'll meet you next time. Thank you for watching.